So here, this is a worksheet for a field speed study. And I believe that most of you did this at some point. So you went out, you had a radar gun, you hide it behind a tree so you don't affect or influence drivers to drive nicely and follow the speed limit. That's always the case. You need to do that, basically. Otherwise, they will think that maybe you'll give them a ticket or something going on. You're undercover cop. So anyways, what we're going to do, we're going to set our speed depending on the speed limit. So we can say, for example, I'm going to have different speed groups. Here we're looking into 30 to 32, 32 to 34 in 2 miles per hour intervals. And then I'm going to count how many vehicles actually at that specific speed group. So for example, if you look at 34 to 36, I have 2 vehicles, passenger cars, 2 trucks, and 1 other. And then you have the total in here. So this is basically the frequency of the speed of cars driving at that specific speed range between 34 to 36. And you keep doing that. The first thing that I'm going to ask you very quickly from these marks actually on the left, what do you see? It's like a normal distribution, exactly. So if I do this, it looks like a normal distribution. Just from the marks actually that you use to count number of speeds in each category. So taking this worksheet, and let's get into some calculations in here to plot the frequency of the speeds and the cumulative frequency of the speed. So what I have in here, this is the speed group between the 32 to 34, 34 to 36 until 64. And then I have the middle speed, which is the middle value in between this. This is 33 miles per hour. And then the observed frequency in each group. So I counted 0 between 32 to 34, counted 5 in this group, and so on and so forth. This is basically the observed number of cars in each speed group. The total is 283. It means that you counted 283 vehicles in there. Then I'm going to calculate the percent frequency in group. So where did I get this 0? Where did I get this 1.8? So now I need to plot the frequency versus the speed. A frequency plot, basically. So it is 5 cars divided by 283 times 100. So this is basically 5 over 283 times 100 in there. And then cumulative is, you're just adding these percentage. So 0 plus 1.8 is 1.8, 1.8 plus, and actually let's calculate this, because 1.8 and 1.8 should be 3.6 in here, but it's not because I'm using the actual numbers. So what I'm going to do in here for this guy, I'm going to say this is basically, let's take an example between 40 and 42 to get the cumulative frequency in there. So what I'm going to do in here, I'm going to say it is 13 plus 7 plus 5 plus 5 plus 0 divided over 283 times 100. This will get me the exact 10.6. So please, if you do that for your homework, do not add up, except if you're using Excel, that's fine. But if you're doing this manually, you use the actual numbers to get the cumulative percentages in there. So you get the accurate number. So it's not 3.6. I'm doing some approximation in there. I'm saying 1.8 and 1.8 should be 3.6. It's not, because I'm using the actual numbers in there. I'm adding the 5 and 5 divided over the 283 times 100 to get this number basically in there. After that, what I'm going to do, I'm going to multiply my frequency in there. So where did I get this? NS. So this is the observed frequency in my group. So here I have, what is the frequency? 5 times the middle speed. Not the upper, not the lower range. So here, this 175, where did we get this 175? This is the frequency 5. This guy basically, multiplied by the 35. excuse my handwriting. It's doing this at an angle. So this is the 175 basically. So I'm adding, I have this NS, which is the frequency times the mid-range. So this speed in here, again the middle range, again the S is the middle range. If you look at the title, the name of this column, this is S basically that you need to use. So I'm multiplying 35 times 5, I get the 175 in there. If you square the 35 and you multiply by 5, you will get into the 6,125 in there. And this is your NS square basically in there. How can we get the mean? So the mu in here is this guy, 13. And I think we mentioned that when we talked about statistics. Statistical application and traffic engineering. We talked about if we're using grouped data, you multiply the middle value times your frequencies, divided, this is the sigma of this, divided by n. So basically your n in here is 283. So if you need to see the actual equation, go back to the statistical applications and traffic engineering notes. You will see the actual equations for these. If we need to get this using this group data, because this is group data, this is not individual data, we need to calculate the standard deviation. How can we calculate the standard deviation? So basically we're talking about the square root of sigma. So my sigma in here, I'm talking about the NS square minus the n times your mu square, and this is divided over n minus 1. These numbers, I already calculated these numbers because ns square, the sigma ns square is this guy. So this is my sigma ns square, 661,691, and this is minus n is 200, this is n basically, 283, multiplied by my mu square. Where is my mu? We just got the mu in here, and this is basically equal 48.1. This is my mu in there, miles per hour for sure. Divide this over 283 minus 1 and minus 1. It will get you your standard deviation of 4.96. Yes.
Is it the summation of the whole thing or just summation of n square? Then there shouldn't be a bracket.
So it is basically the 661,691 minus 283 multiplied by 48.1 square. So you multiply 283 minus this, multiplied by the 48.1, the mu in there. You square this. You divide by n minus 1, which is 283 minus 1. You take the square root. It will get you the standard deviation. Yeah, okay, so this is what you mean. So I need to take this off, and this is basically, it's like this. So the summation of the ns square is this guy. And this is minus your n multiplied by the mu square. So actually it is 48.1 square multiplied by 283 divided by 283 minus 1. You take the square root, it will get you the standard deviation. And again, go back to the original equation in the statistical application notes we had last time. So after that, what you need to do, you need to plot the frequency distribution curve, which basically this guy in here, for each speed group. So the percent frequency of observation within the group is plotted versus the middle speed of the group. This is really very important. So the percent in here, this column 1, 2, 3, 4, 5, this column number 5 is plotted versus the middle speed. The cumulative frequency, however, is plotted versus the higher boundary of the speed. So let's say this guy in here, this is your middle speed range. This guy in here, this is the higher boundary. Okay, so your percent frequency is against the middle speed. Your cumulative frequency is against the higher boundary of your speed. And then you plot these, you fit a curve in between, and my first question to you, where is the model speed value? Where is the mode? So we calculated the mean now as a measure of central tendency. The modal speed is the peak, this guy in here, the highest value on the curve, which basically in here we're talking about 49.9 miles per hour. Where is the pace? The pace, I'm going to use a scale of 10 miles per hour on a piece of paper, and I will slide this on the curve until I hit the 2 points on the curve, and then I'm going to go down like this to the cumulative frequency curve. I'm going to see what is the percent, the cumulative percent, what is the cumulative percent in here, and then I'm going to say that the vehicle in pace is between 87% and 14%. So we have 73%. So the 10-mile pace encompasses 73% of all vehicles. So 73% of my vehicles within a speed of this value and this value. So we have 73% of the vehicles within the 10 miles, which basically it looks like here 43 something miles per hour to 53 miles per hour. This is the speed, the 73% of my vehicles is within that pace in there. And again, if I need to get the median usually it's hard to calculate mathematically. So from the cumulative curve in here, if I had the 50% cumulative percent, this is your median, the 50 percentile, which is 48 miles per hour. And if I need to get the variance from this, how can I get the variance? The variance, look at the 15th percentile and the 85th percentile speeds, and you get these two speeds, and you need to get these speeds actually here. Divided over 2, you get your standard deviation. And if you do that, you will get a standard deviation, I believe, of 4.5, very close to what you calculated mathematically. So from the graph, if I give you in the midterm exam, a graph like this, you need to be able to provide me with the modal speed, the pace, you need to get me the median, and you need to get me the variance as well, which is 85th percentile speed minus the 15th percentile speed divided over 2. If we need to calculate the sample size for a specific standard deviation in here, and anyone remembers, where did we get the standard deviation? You remember the table in the previous notes? The table will tell you that the standard deviation mostly is 5 miles per hour. This is not from the example. Now I'm trying to see at a tolerance of 1 miles per hour at 95% confidence, what would be my sample size? So I'm saying that n equal to 1.96 square. So this is basically 1.96 square multiplied by the standard deviation square divided by the tolerance square. You need 96 observations. Or if I need to push this with a better tolerance with 0.5 miles per hour, you need about 384. In this example, we have only 283 observations. So let's get into the chi-square. Now we assume this is normally distributed. Is it really normally distributed or not? This is what we need to do in here. And I need to conduct a chi-square test. And let's say I'm going to name these columns as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And I'm going to show you how to get these numbers, because you need this as well. So let's take the 48 to 50 as an example. The frequency observed is 62. What we need to get in here, we need to compare a theoretical frequency to the observed frequency. So this is basically the core of a chi-square test. If this really normally distributed, the frequency in that category should be the 44, not the 62. But we will see if these frequencies for everyone is typical to the theoretical frequency. So the concept of a chi-square test is comparing a theoretical frequency. So we're saying if this is really normally distributed, in each category, you should have this frequency. This is what we call the theoretical frequency, column number 7. So now we need to calculate the theoretical frequency. This is what should be if it's really normally distributed. And we need to compare this to the actual observed frequency. So what we're going to do, we're going to start with getting the upper limit standard normal, z. Anyone remember where can we get this z values? So the z for, let's say in here, this is z for, this is basically the 38 in here, I'm calculating this. This is my standard normal for 50, which basically it's going to equal my x50 minus the mean divided by the standard deviation. So this is basically, I'm using the upper boundary in here. This is 50 minus, we calculated the mean as 48.1, divided over the standard deviation. Standard deviation in here is 4.96. This will get you into the 0.38 in there. So this is basically this column number 4. Where I get this from, you remember the standard normal tables? You need to use the standard normal tables I provided you in the statistical application notes. And you go with the 0.38. So you read from the left 0.3 and 0.8 on the column, you will get into this value. And this is basically the probability of having the speed of 50. Your speed is less than or equal to 50 miles per hour, as we did previously. So this is basically the value in here, this guy in here. Where did we get this probability of occurrence in that group? So basically in that group, I need to look into my speed between 50 miles per hour and 48 miles per hour. In order for me to do that, now I need to get the speed that is less than 50. We just calculated the probability of the speed less than or equal to 50 miles per hour, which is 0.648 from the standard normal tables. And what is the probability of having the speed actually? What? There is a delay. It shows up in here, so I'm putting the 49 in here. I circled the 49, the 0.49 in here, this guy. So let's see this. Again, you will do this. So this column number 5, basically after calculating the probability of each range, and you use this for the upper range. So you do it for 60 miles per hour, you get 2.4. You do it for, let's use a different color. You get this 2.4, 2 for the 58, 1.59 for the 56. And then these numbers on column 5 basically is the probability from the Z table. And then this number, the probability of occurrence in that specific group as we did before, this is basically the 0.648 minus 0.4920. Because again, I'm looking into the probability of Z less than the 0.38 and less than negative 0.02. You will get the 1 with a 0.1560. This is the probability within that specific group, as we calculated before probability of speeds. We had an example like this before. Then where this theoretical frequency 44 actually came from in here. So this is basically the 44 is the 0.1560 multiplied by 283. So now I have the probability of having speeds within the range of 48 to 50 miles per hour is about 15.6%. We have 283 observations. If you multiply your probability times number of observation 283, you should have 14 observation in there. And this is the theoretical frequency if this is really normally distributed. And then we're going to do this combined groups and combined group of the actual observed frequency and the theoretical frequency. So where this 7 came from? Chi-square test won't work for frequencies less than 5. So that's why I actually added the observed frequency for the first group and second group. I put it in here. I did this for the last one. I added these 5s. I got the 10 in here. Because if you have a frequency less than 5, you need to combine the previous group to it, and you get a greater frequency than 5 in there. So we have the 7 and 10. We're going to do the same thing for the theoretical frequency. So I'm adding this 2.3 and 4.1 in here. I'm adding these two guys in there. And now I'm getting a combined group frequencies greater than 5 in these cells. How can we get the chi-square itself? So basically chi-square, this number specifically, is equal to, so I'm going to write maybe the chi-square test in here. So my chi-square is equal to Ni, which is basically the observed frequency, minus your theoretical frequency square, divided by the theoretical frequency for that specific speed group. So let's take an example of calculating chi-square for a speed group of 48 to 50 miles per hour. So what was the observed frequency for 48 to 50? 62. And what is the theoretical? 44. So basically this should equal to 62 minus 44.1480. This is all square divided by the 44.1480. And this will get you into a frequency or a chi-square of 7.2 for that guy. So this is basically the 7.2 we got in here. We will calculate this for each speed group, and then you will add all of these numbers together, and this is basically your chi-square. What you need to do, you need to compare this chi-square to the degree of freedom chi-square for this example. And the degree of freedom for this example is equal to 12 minus 3. So the degree of freedom here is 12 minus 3 equal 9. Why? Where did I get these numbers from? I have 12 speed groups, and I have 3 unknowns that I need to know, basically my mean, standard deviation, and the sample size, number of observation. This is where I got these 3 from. So that's why I'm subtracting 3 from 12 speed groups. I got degree of freedom equal to 9. And I'm going quickly to show you where to compare your... So from this table, this is a degree of freedom 9. And we got 14. So I'm looking at this row for 14. So actually I don't have the 14 point. What was the value again? 14.35. We don't have 14.35. So what you need to do is you need to interpolate between these. Get your probabilities in here, and I can tell you very clearly that the probability is between 10% and 25%. It is gonna be greater than 5%. So this is basically is normally distributed at 95% confidence.